So the next idea is going to be scalar product. So you know what scalar means, right? Scalar means number. So a vector and a scalar, those are the two types of mathematical objects that you know of so far.
Yes.
Vectors are things that have directions and magnitudes. Scalars are things that just have magnitudes. So what is a scalar product? So far, if you've noticed, we haven't talked about any kind of vector to vector multiplication.
Mm-hmm.
Like we never discussed how to multiply two vectors together. So now this is the first kind of multiplication of two vectors that we're going to learn about. So it's honestly very simple. So if you have two vectors like A, B, C, and you want to find the scalar product of these two guys, A, B, C, D, E, F. First
Mm-hmm.
of all, we also call it the dot product, by the way, for
Mm-hmm.
a very obvious reason, because it's signified by a dot.
Mm-hmm.
And the product simply goes like this. You multiply each of the corresponding terms, okay, and
Mm-hmm.
add up their multiplications basically.
Okay.
You see? AD
Mm-hmm.
plus BE plus CF. And as you can see, the number you're getting is not a vector. It's literally a number,
Yeah.
right? This is going to end up being a single number. No vector, no nothing. That's why it's called a scalar product because it gives you a scalar number.
Right. Okay.
Now, this is how you calculate the scalar product like explicitly. Okay.
Mm-hmm. Okay.
However, it has a very interesting use. So basically, if you have two vectors like 2, 1 and 4, 3, okay, and you find, so I'm going to explain this by example. If you find their dot product, so this is A, let's say, and this is B.
Mm-hmm.
If you find A dot B, it'll be 2 times 4 plus 1 times 3, which is 11.
Mm-hmm.
What does this mean? The value of the dot product is you can imagine, you can kind of visualize it in your head as how much are these two vectors pointing in the same direction? Like how strongly are they pointing in the same direction?
Okay.
Okay, so if the two vectors are perfectly parallel, you will expect an infinite dot product. And if
Mm-hmm.
they're like, if they're a bit far off, then you will expect a smaller than infinite. And if they're perfectly perpendicular to 90 degrees to each other, what do you expect as the dot product?
90.
The dot product is like, it's not exactly the angle, it's like a feeling for how much they're pointing in the same direction. So you're expecting zero in this case, right? Because they're not pointing in the same direction
Yeah.
at all. So
Okay.
that's what the intuition behind dot product is. Of
All
course,
right.
this is very loose, right? It's not exactly something formal, but I'm just trying to give you the idea about what I'm about to drop on you in a bit. The
Okay.
thing is, the dot product, now that we know how to calculate it, the interesting thing about the dot product is the number you get from the dot product will always be exactly equal to the product of the two vectors' magnitudes
Mm-hmm.
times cosine of the angle between them.
Mm.
So
Okay.
whenever you get the dot product number, it'll be exactly equal to this, where theta is the angle between them.
Mm-hmm.
Okay? So
Okay.
in this case, for instance, the angle between, so let's first try to like roughly sketch A and B. So A would look something like this, or let's say this, and B would look something like this. You see how the angle between them is very tiny? I mean, at least it
Yes.
looks tiny from this small scaled graph.
Mm-hmm.
We can find the exact angle between them using this formula. Okay. So
Yeah.
first find out their dot product, which you've already found.
Mm-hmm.
Then find out their individual magnitudes. The magnitude of A is 2 squared plus 1 squared square root.
Mm-hmm.
Magnitude of B is 4 squared plus 3 squared square root, which is 16 plus 9, which is 25. That's going to be exactly 5. And then
Mm-hmm.
plug everything into the formula. We don't know the angle yet, so we can't plug in anything there.
Mm-hmm.
11 equals the root of 5
Mm-hmm.
times 5 times cosine of the angle between them. If I
Okay.
divide both sides by this mess,
Mm-hmm.
I'll end up with this. And finally, theta will simply be the cosine inverse of 11
Of that.
over 5, right, 5 root 5, which tells
Okay.
you the angle between the two vectors directly. Okay?
Got it. Got it.
So that's the main, purpose of the dot product. It tells you the angle between two vectors. So you can
Okay.
like, calculate this as cosine inverse of 11 over 5 root 5, and that gives you 10 degrees, which is a tiny, tiny angle.
Mm-hmm.
10 degrees is like
Yeah.
this much, right?
Yeah.
Or basically that much, the one I just drew.
Mm-hmm. Mm-hmm.
So, here's another interesting use case of the cosine rule. Note that the key driver about the angle of the dot of between two vectors depends on
Mm-hmm.
cosine of theta, right?
Mm-hmm.
So the dot product has cosine theta. Dot product has a factor of cosine theta in it. And the thing with cosine theta is that when the theta is zero, when the angle between two vectors is zero, we get a 1 out of it.
Mm-hmm.
And when the angle between two vectors is 90 degrees, meaning they're perpendicular, what is cosine of 90?
0.
0. Because they're not pointing in the same direction at all. Okay?
Yes. Okay.
So, because of this fact, whenever two, so I'm going to type this out. This is one of the biggest claims.
Okay.
Whenever, so the dot product of two perpendicular vectors is always equal to 0. Okay?
Okay. Got it.
Can I say, by the way, that the dot product of two parallel vectors will always be equal to 1?
Mm, yes.
Sounds about right, doesn't it?
Yeah.
But it's a trick. See, if you look at the dot product formula, just because this is 1 doesn't mean that the whole thing is going to be 1, is it? Because
Yeah.
it's actually going to be equal to the product of their magnitudes if they're parallel.
Mm-hmm.
Okay? So it's not going to be directly 1. But in the case where they're perpendicular, because of cosine theta becoming 0, because of this guy becoming 0, it takes everything down with it,
Yeah.
turns everything to 0. So the dot product being 0 when two vectors are perpendicular is a very useful little
Uh,
conclusion.
okay.
Any questions?
No, understood.
Perfect. So that's basically it. That's the idea. Let's see. By the way, if they're 3D vectors, the idea stays exactly the same, okay? So the
Okay.
dot product is the same, all the ideas are the same.
Got it.
Now, let's do a quick question
Mm-hmm.
where we're going to use the fact that, the dot product is 0 when they're perpendicular.
Mm-hmm.
So you have two vectors OP and OQ,
Mm-hmm.
and you want to find the value of K such that the two vectors are perpendicular to each other.
Right.
Now, if they're perpendicular to each other, what claim can we make?
Their what is it called? Their dot products are 0.
Yeah, their dot product singular is 0 because, you're multiplying them together, so
Yeah.
you're going to get a single dot product out of it, which
Yes.
is going to be 5K times K plus negative 3 times K plus 2
Mm-hmm.
plus 7K plus 9 times negative 1. So again, I literally just multiplied 5K with K, this with this with
Mm-hmm.
this.
Okay.
And this has to be equal to 0 because they are perpendicular to one another. Okay?
Okay.
And that's basically it. So you'll just, solve this equation for K and call it a day. Okay?
Okay. Mm-hmm.
For the second part, it says now that imagine that K was 2. So if K is 2,
Right.
then you know what OP is and you know what OQ is, right?
Yeah.
K is 2, then OP would be 10, negative 3, and 23.
Mm-hmm.
And OQ would be 2, 4, and
Negative.
negative 1. And then you
Yes.
can basically find the angle between them using exactly what I just showed you earlier. You
Yes.
know, so so you're gonna set up this equation,
Yep.
find their dot product using the basic dot product like method, find their individual magnitudes, plug everything into the formula, and that's
Yep.
basically it. So
Okay.
that's dot product. That's everything you need to know about dot products.
Okay.
Um, Now I believe the cross product is not discussed yet. Yeah, it's gonna be talked about later. Finally, we come to the vector equation of a line, the thing that
Okay.
started all of this. I'm
Okay.
very happy though that we get to cover the whole chapter because of one single question.
Mm-hmm.
The vector equation of a line. You're gonna see that everything I've explained so far is like vital to understanding everything now.
Okay.
Now, we've already talked about how to write down the algebraic equation of a line. It's y equals mx plus c, right?
Mm-hmm.
We're going to use a similar kind of idea to write down a vector equation. Now, here's the way I want to explain it. Look, whenever you draw a line or a vector line, right, the
Okay.
vector starts at some point. You can imagine, it doesn't need to start at its tail, by the way, you can start it anywhere. Okay, imagine that you started at point A, or let's call it um, A1, A2, A3. So
Okay.
this is the coordinates or the position vector of point A, where the vector is, I'm saying that it's starting. Okay, of course, it's not visually starting there, but we call it a starting point or an initial point. This is our basis. You can
Okay.
move along this line in both directions, so it doesn't matter that it's not at the exact tail of it,
Okay.
regardless. And by the way, okay, never mind. So this is the starting point. We call this R naught. So with a little zero at the top, we call this R NAUGHT. Nobody types it like that, but that's the
Mhm.
word R naught. Okay.
Okay. Okay.
Which is also called the initial point. This is, by the way, I know I'm saying it again and again, but it's very important because in the exams they're going to say the initial point is this, and you can get
Okay.
confused. So initial point. Now we need one more point on this vector to write down the equation. Because
Mhm.
obviously, if I just have one point, the vector could have been anything. It could have like, you know, oh shit. It could have been any one of these vectors. As long as it passes through one point, that's not enough information. So I need one more point on the line.
Yes.
Let's call it point B. Now, this line is unique. There is no other line in the universe that passes through these 2 points. I mean, of course, the longer and shorter versions of this will be, but this is the only this directional line that passes through A and B, right?
Mhm.
Okay. So now that you know 2 points on the um, vector, right? By the way, when I say no 2 points, I'm actually telling you they're position vectors. These are technically coordinates also because they're pretty,
Okay.
the same thing. But I know the position vectors of 2 points on this vector. I can build the vector equation of this line very easily now. How?
Right.
What I do is I say that um, I need one direction. So I need two things for the vector equation. I need a direction and I need an initial point. And technically I have both of them at this point, don't I?
Mhm.
Because I know an initial point, A1, A2, A3. I can also use the B1, B2, B3 as an initial point, but I've written all of this, so I don't want to do that anymore. So
Okay.
the initial point, I can choose any point on the line, any point. So in this case, for example, I'm using A1, A2, A3. Okay.
Okay.
And
Mhm.
direction, we're gonna need to use 2 points on the line to find the direction. Okay.
Okay.
Of course, there are two separate vectors here. There's AB and there's BA. So I'm assuming that I want to find the equation of vector AB. Okay. So the
Yes.
direction of AB is B1 minus A1, B2 minus A2, B3 minus A3, right?
Mhm.
Because this direction basically is what I'm
Yes.
talking about. Okay. And now all I gotta do is put it together. I will say that my vector equation is R equals the initial point. So I'm
Mhm.
gonna say R naught plus I forgot what this guy is called. I think it's called a parameter, but I want to check what its name is. T parameter. Yes, it's just called a parameter. So T times the direction. So we call, I don't know what the name for the direction is, but direction vector.
Okay.
This is how your vector equation will look. Okay. This
Mhm.
is called a parameter. I'll explain its purpose in a second.
Mhm.
But let's put it together first. So R equals the initial point plus the parameter times the direction vector.
Mhm.
Now, what is t? So what is this parameter? By the way, the parameter is sometimes even called lambda, mu, can be called anything. Alpha, beta,
Okay.
gamma, can be
Okay.
anything. Okay, just not xy because xy are kind of weird because
Okay.
they're already the x and y coordinates, so they're already taken basically. Now,
Mhm.
how does this work? Think about it like this, okay? This is my way to think about it. A vector is a line, and you put a person on this line, and that person is originally standing at A1, A2, A3. Okay?
Mhm.
and you tell the person you can only move along this direction. And this direction means you can move in that direction or that direction, basically. Because you never said, like in the positive or the negative. You're just saying on this line, basically. Because this is a line, right? This is a vector equation almost. This is a
Okay.
vector. Because when you do b minus a, you get a vector. So
Hmm.
now what is t here? T is the steps that this person is going to take. If you're standing at A1, A2, A3, and you add 4 steps in this direction, you will end up moving boom, 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 boom. You'll end up here.
Hmm.
You see? So now
Okay.
since t is a variable that can be anything, this guy can end up anywhere on this entire line. If t is 1, he'll end up here. If t is 0.5, he'll end up here. If t is minus 2, he'll end up here. And that
Okay.
way, we get all of these different positions that this guy can end up on by just changing the value of the parameter t. So t is how far, or the stepping basically. How many steps are you taking
Okay.
in this direction? So this is where you're starting and you're adding steps in this direction. That's
Hmm.
what's happening. Okay.
Got it.
So this is the kind of the way I visualize this equation, and it's super easy. So again, maybe, now that you have seen the general example, let's take a look at example question. So far, kind of making sense. If it doesn't make
Yeah.
fully make sense so far, it's not a really big problem. You'll see it now.
Okay.
So there's a line. It passes through this position vector, okay,
Hmm.
and it is parallel to the vector given here, okay.
Okay.
So when I say parallel to the vector given here, that means I've given you a direction, haven't I? Because
Yeah.
parallel to a vector means I've told you this is the direction that you're moving in, right?
Yeah.
So this tells you the direction,
Okay.
which is given as 1, negative 1, 1. Okay,
Hmm.
so
Okay.
good. We know the direction. Now all we need is an initial point. What do you think is the initial point?
Um, the position vector
Yeah,
3i.
there's no other option really. So
Yeah.
3, negative 2, 4. That's the position. That's the initial point. Remember, initial point you can literally pick anywhere. It doesn't change anything at all.
Okay.
Okay.
Hmm.
Again, we call this R naught. Now, the vector equation of this line will therefore be R equals, what do you think?
R equals the initial.
Mm-hmm.
So 3, negative 2, 4
Good.
plus t I minus 3i.
I minus 3i, where'd that
Or
come from?
no, there isn't a second point. So is
Yeah,
it just
because you know the direction from this idea directly. You don't need to find a direction like manually. Because when they say parallel to a vector, they've given you the direction automatically.
okay?
Because if you're parallel to this vector, that's your direction. That's the direction you're pointing in, because you're
Hmm.
parallel to it. So the direction is simply this.
Oh,
Like,
okay.
yeah, because being parallel to a vector is me saying you are pointing in the same direction as this vector.
Hmm.
And so you can just directly use this vector itself as the direction. You see?
Okay. Hmm.
So that is basically it. That's the vector equation. Okay.
Hmm.
Now, what is the parametric equations of the line? This is something that I didn't study when I was going into my exam, and I had to kind of come up with the solution myself. I still remember because I
Okay.
didn't realize this was a thing. But it's
Hmm.
very easy to understand. You see, R is basically positions, right? As I said, like when you add the initial position with how many steps you're moving in this direction, you will
Yes.
end up at various positions. And how are positions defined? X, Y, Z, right?
Hmm.
Every position on our universe is defined by XYZ values. So
Yes.
R is truly X, Y, Z. Now, why is that useful? It's because you can parameterize 3 separate equations, one for X,
Hmm.
one for Y, and one for Z. So you can pull out 3 equations from this. X equals 3 plus T, 3 plus 1 times T. Y
Hmm.
equals minus T, minus 2 plus T times negative 1.
Hmm.
And Z equals 4 plus T times 1. This gives you 3 separate parametric equations
Okay.
for X, Y, and Z separately. So you can, if I move 10 steps in this direction starting at this point, what will just my Y value be? You can just directly plug in 10 steps over here and get the answer. you see?
Hmm.
So if you're only worried about one of the coordinates, you can use this to find it out.
Okay.
And again, just to clarify again, for example, if I say what is the new position when t is, I don't know, -2, you can simply plug in t is -2 right there and solve for r. It's going to be 3 minus 2.
Hmm.
What is the y value going to be? What's the second value going to be? Sorry.
-2 plus 2,
Yeah, which is
0.
good. And what's the third value?
4 plus or negative -2. So 2.
So 2. That's the
Yes.
new position, which means that you will end up at this coordinate. So you can actually convert it to an XYZ coordinate too. You see?
Okay.
So
Okay.
another cool little thing. So that's basically it. That's what a that's what a vector equation is. That's how you find it. That's the intuition behind it.
Hmm.
But questions about this topic are pretty tough. So for the
Okay.
time being, try, I would say most of the questions from exercise 9D, they are the basic kind. Okay. And if
Okay.
you want, you can try out trying to understand 9.5, but it's a bit of a difficult kind of idea. We'll talk about that in the next class. But for
Okay.
now, make sure everything, the dot product and the vector equations, setting them up and etc., and
Hmm.
kind of visualizing them even, is
Okay.
very clear in your head. Because once we get going from this point onwards, we're gonna basically finish off this chapter with the most difficult questions. There's one thing left, by the way, just one more thing.
Okay.
But over there, that's where the difficult stuff is gonna show up. So yeah, that's
Nine.
basically it.